Okay, so 3 friends that work together take turns bringing food. And so Peyton is first. And Peyton brings 8 cinnamon crunch bagels and 2 things of cream cheese. So what is the possible cost for a bagel and a cream cheese if he spent $19.50?
$7.50 for 8 of them, 12 for 2 tubs.
What?
Who's talking?
How much per bagel and how much per tub?
Singular?
Yeah.
0.39 for a bagel and $6 for a tub.
I got 2.25 per bagel and 75 cents per tub.
All right.
8
There's
ounces?
how many possibilities are there?
A lot.
Infinitely many possibilities. So
I got $12
you can do $12 bagels if they bought 8 and they were $19.50. I said my bagels were $2 and my cream cheese was $1.75. But that obviously there's multiple ways. As long as you do 8 times the number of bagels plus 2 times the number, 8 times the price of the bagel plus 2 times the price of the cream cheese and get $19.50. They're all right answers.
$1.50 for a bagel.
We'll see if anybody guessed right when we get to the end. So Kelly bought 4 bagels and 1 tub of cream cheese. Do we know how much Kelly spent?
No, we can find out.
We do know how much she spent. Landon figured it out. I heard him say it. Half of it. So $9.75 because she bought half as many bagels and half as much cream cheese, so she should pay half as much. All right, and then number 2 says to find the cost of a bagel and a single tub of cream cheese, or explain why this is not possible. It is not possible. There's not enough information. We have 2 different situations, but because they're the same representation of it's the other situation, and we don't have enough to solve it. Okay, but Carter's going to save us. So Carter decided he was going to buy more bagels. He bought 13 and double amount of cream cheese. Should Carter's subtotal be double Peyton's?
No, ma'am.
No. He didn't double the bagels. Okay. So we know how much Carter spent on his 13 bagels. So we're going to have x be number of bagels. So 13x plus 4y should be 34.53. Let's see if we can figure out the cost of a single bagel. So underneath that, I'm going to line up the equation for Peyton with his 8 bagels and his 2 cream cheeses. Now, my other class on the day that we watched the clips, I did a couple of examples of elimination, which is this lesson is on elimination. I didn't do that for you all, but you might remember it. When we do elimination, you want to take either the X's or the Y's and try to make them opposites, where it's the same number but a different sign. Which one of those would be easier to do in this case? The Y's, right? What would I need to multiply the second equation by? 2 or negative 2. We want them to be one to be 4y and the other one to be negative 4y. We're going to multiply by negative 2. So the top equation is going to stay exactly the same. Oops. And the second one, we are going to multiply by negative 2. And then, because they're opposites, now we can just add, and they should all be lined up. Your like terms should be lined up. So when we add, the y's are eliminated. That's why it's called the elimination method. And then we would divide by that negative 3. Oh, sorry, that should be an x, not a y, my bad. Divide by that negative 3, and the bagel cost $1.49. Does anybody have $1.50 bagels?
I did.
That's
Good job. You're really, really close. Just 1 penny off. All right, and then we want to find out how much the cream cheese costs. So I can take that $1.49 and I can put it in for any of these x's that I wanted to. I'm going to go ahead and use this one right here before we multiply by -2. So Peyton's equation, just because the numbers are just a little bit smaller. That's an 8. I'm sorry, I'm having a hard time writing the right numbers. All right, then I'll just go ahead and subtract that 11.92 and then divide by 2. And each cream cheese costs $3.79.
Cream cheese, blue bacon.
Well, if you think about it, we were talking about this earlier. It's 8 ounces of cream cheese. It's like the same as a block of cream cheese, and that there, yeah, it's a whole ton. Yeah, it's not a.
I'm not paying.
It doesn't tell you how many servings, but yeah, it's like 8 servings of cream cheese. Cream cheese is expensive. Any dairy product is expensive. More expensive than a single bagel for sure. Okay, let's look at the back, and we're going to do some notes. In this box, we're mainly just going to talk about the different types of solutions we can have to a system of equation. And we talked about it, I think the very first day, we talked about systems of equations. We talked about inconsistent systems, but we're going to talk a little bit more about that today. All right, so a system of linear equations can be consistent or inconsistent. All right. Consistent means that you do have a solution. Inconsistent means there's no solution. So you can have solutions two different ways. Independent and dependent. Right. Independent is when there's just one solution where it's like an X where they cross at one place. And dependent is when there are infinitely many solutions. So one line gets graphed right on top of the other line. My Apple Pencil just died for a second. All right, and then an inconsistent system, there's no solution. So if it's a linear system, that means that they're parallel lines. All right, so let's pretend that you're a third grade teacher and your students are making pencil cups and snowman crafts out of popsicle sticks. And you know that it takes 271 popsicle sticks to make 7 pencil cups and 15 snowmen, and it takes 373 popsicle sticks to make 14 pencil cups and 15 snowmen. How many popsicle sticks are needed for one snowman? Okay, so I'm going to have the number of popsicle sticks it takes for a pencil cup to be X and snowman to be Y. All right, so if I take 8X plus 15Y, what should that equal?
271.
Yes. And then 14X plus 15Y is 373. And this is the absolute perfect one to do by elimination. All the other methods that we've learned would be crazy difficult to do on this one, but elimination is super easy because they're already 15s. And so all we really need to do is subtract these or just change all the signs on one of them. Just pick one, change all the signs. And then when you add, you're going to get negative 6x equals, I don't know why I don't have this written down. Negative 102. So x is 17. Is that the answer to the question?
No.
No. That is the number for a pencil cup. So you just plug it into any of them. I'm going to go ahead and do the top one. Oh, my goodness. All right, so that's 9 popsicle sticks for a snowman.
They don't seem.
I've never made a snowman out of popsicle sticks, but I'm sure they're cute. Okay, on number 2, we want to consider the system below. And then A, we're going to write an equivalent equation of one of the given equations that would help you eliminate a variable. So looking at the system, which would be easier to eliminate, X or Y?
The Y.
Yes, because 6 is a multiple of 2. What would I need to multiply that top equation by?
3.
Nice job. So let's go ahead and do that. The reason we picked Y is because 6 is a multiple of 2. Okay, and then we're going to solve. So I'm going to go ahead and use that new equation I just found by multiplying by 3. The original old equation for the second one. Now we do get kind of an ugly answer here, but it doesn't matter. It's fine. So when we divide, we're going to get a fraction that's 45/19. That's okay. That's what X is. All right, and then we can find Y by plugging that into any of the X's. It's going to be an ugly decimal no matter what we do. But luckily, your calculator is super smart and it takes care of ugly decimals just fine. So when I multiply by 4, I get 180/19. This needs to charge for longer than 2 seconds. All right, and then when I subtract 180 over 19 from 10, I'm going to get 10 over 19. And then when I divide by 2, negative 2 is going to be negative 5 over 19. So don't get worried if you get some weird fractions. It's okay. Not everything turns out just perfectly. All right, and then number 3, we want to find the value of the constant k so the system has infinitely many solutions. When there's infinitely many solutions, it is the same line. So I want to multiply negative 10 by something that's going to make it 22. And that same thing should also make negative 5 11. Anybody know what it is? It's kind of a weirdish decimal. It is going to be negative, by the way. So we're not. It's 2 point something. We're not really trying to solve this equation. We're trying to make the coefficients and the x and y be the same so we can figure out what k is. 2 point. I want to get 10 to turn into 22.
2.2.
Yeah. All right. So we get 22x plus 11y equals negative 6.6. If I want these to be the same, I want k to be negative 6.6. All right, so if you're asked to find something to make it infinitely many solutions, you want the equations to be the same. All right, and then the last one, we don't have to solve this. We just have to do enough work to decide if it's independent, dependent, or inconsistent. So one solution, infinitely many solutions, because it's the same line, or no solution. So before I do that on A, I would go ahead and I would line up my like terms. So I would move the 3x over under the x, but because I moved it across the equation, I would have to change the sign. All right, so what do you guys want to try to eliminate? If we're using those two. So if I'm going to eliminate y, I would multiply this one by 9. So what happens to the x and the y? Yeah, the x and the y both get eliminated, which leaves you with 0 equals negative 27. Can 0 ever equal negative 27? So that means there's no solution and it's an inconsistent. I think there's a glitch in my brain. Put the I in the wrong place. It's an inconsistent. Oh no, I just spelled it wrong. There we go. All right. Now B, we don't have to solve the whole thing, but it is one of the more difficult kinds because there's not like an integer. We can multiply 6 by to make it, or 4 by to make it 6, or 2 by to make it 5. We can do a decimal if you want to. My last class just wanted to go ahead and just multiply both of them by something. So what can you make 6 and 4 both become? What is there something smaller than 24? We can make them both 12. So if we wanted to make 6 12 or negative 12, we would multiply it by 2. And then the other equation, if I want to make 4 12, I'm going to multiply it by 3. Oops, I messed up. All right. I don't have to solve this. I know if I add, my x's will be eliminated. I'll have some y's. It will equal 70. This one is going to have one solution, so it's independent. All right, now I do want to make a note of what it's going to look like if it's dependent. So if the answer is going to be dependent, whenever you're solving, the x's and y's will be eliminated. You'll get 0 equals 0. You'll get something true. You would never get 0 equals 5 or something like that for dependent.